Hey guys, welcome to our discussion of Lab 3. So this is where we're going to talk about the more specific details of what you need to do and how you need to do it. So again, this lab is in the lab manual, and if I'm not mistaken, this is pages 23 through 27. So it's pretty long. The lecture portion has exactly where the objective and the equations and the Ka and all of that are, so I'm not going to go through that. But I am going to talk about what we need to do for the pre-lab. That's the first thing. And then we'll talk about what goes on in the summary and the post-lab. So your pre-lab needs to include all of the tables that are here. Now, those tables will need to include all of the data that you see in this data sheet. Okay, so this data sheet can be found in D2L, good content, exam 1, titrations, go down to the acid-base titration lab. And you'll see that this right here says experiment 3 data. So that's the information that needs to get put into your lab notebook. So there is that. So that's all of this data that needs to go in there. There are a couple of things that are on this paperwork that you need to make sure that you've recorded. So one is where the color changes. That is your endpoint. The other thing is it'll say phenolphthalein, that one does, and the other one says methyl red. Those are your indicators. So make sure that you've included that right here where it says indicator. I would set these up as, and where does it say? That's a good question. So your volume of the material that you started with, we can assume that that's 25.00. Okay. It may not have been exactly that much. So it says 25 mils of the approximately 0.2 molar HCl into 50 mils of distilled water in a clean 250 milliliter beaker. So your total volume there is going to be 75 mils. You'll need that eventually to do calculations, but make sure that you've indicated how much of that solution you took. Your volume of HCl right here would be that 25 mils. And include that for both of these, because I'm pretty sure it says 25 for both. So that's what needs to go there. Now, there is a spreadsheet that goes with this experiment, and that spreadsheet is this. And what you'll see in that spreadsheet is that there's a yellow area where you're supposed to put the volume and the pH, and then all the way down, and then it will generate a curve for you. That printout of those curves is what you will need to be able to do the box analysis that we're going to talk about. So that's what you're going to need to do for that. And then we'll talk about the rest of this as we keep moving forward. So you will need to calculate a titration error. And that formula should be in your lab notebook. And your titration error is going to be your absolute value, your actual minus your theoretical over the theoretical, and that's times 100. So you're looking for a percentage that this is different, okay? And we always do it as the absolute value of actual minus theoretical because we just need to make sure that we know how different they are, not which direction. And we do it over the theoretical because we want to know what percentage of the theoretical this is. Now your actual, as I mentioned before, is going to be that end point that is listed, and your theoretical is the equivalence point that you determined from the graph. So again, the endpoint is in the data as where it changed color. The equivalence point we're going to determine for the graphs that we create. Okay, so that's everything for your pre-lab. Now, when we move into the summary for this, oh yeah, change pages, that's helpful. Your objective, the reaction for the neutralization reactions are in the lab manual. The lecture tells you exactly what pages they're on if you need to find them. The one for the first titration is not actually in there, but you're looking at the reaction between NaOH and HCl. So I'll let you write that. I'm pretty sure you can. But if you have any issues with it, talk to me. It says calculations, complete a titration curve. That's what you're going to do in the spreadsheet. Make sure you print that to PDF and send it to me because I need to be able to see that. And using the graphical determination method, determine the equivalence point volume of the titrant required for each of these titrations. Show your work on the printed titration curves. Note the volumes here. Okay, so what are we talking about with that? Well, if you scroll down in here, you'll see this lovely little graph. And what this means is that you're going to have a titration curve, which goes here and up and over, right? So that's what you're going to see from your titration curve from the Excel. So general shape is going to look like, well, for one of them like that, and for the other one like this, okay? And what they're talking about is you create a line that extends from where this is flat right here all the way over. So you just draw a straight line from that line all the way over. Same is going to be true on the top part. Once it flattens out, you're going to draw another line, and then that generates the top and the bottom of this, okay? You draw a line down and a line down, and then once you've got the four sides of the box, then you want to draw the two diagonals. And where those two diagonals meet, that is your equivalence point. So you want to find that equivalence point, and then find what the exact volume is at that equivalence point, and from that, find the pH at that equivalence point. Okay, so that's how you're going to determine the equivalence point that you use for those calculations, right? This is not that hard to do. It may not be pretty, but that's fine. Just do it. You should use a ruler, do it that way. It'll be okay. The data's a little messy to do it with. We don't necessarily have that much up on this side, but we will be okay. And you can do it for both experiments, this one and the one below. Okay, so again, you're going to draw one sort of here-ish and then down here-ish. And of course, we hope that this is going to be all on one piece of paper so that you can do that. So try, when you do save it as a PDF, try and get those images on one graph so that you can make that work. Okay, so that's how we're going to do that part of it. And it tells you to do that, and you'll need to calculate what the equivalence point is. And then once you know the volume of the equivalence point, you can find the volume of the half titration volume. And once you know that volume, you can find out what the pH is there, and the pH is equal to the pKa for that acid and or base, depending on what we're talking about. So it's either pKa or pKb. So that's how you'll get that when we get to that. Now, so there's that part of it. So that's what we're looking at for the calculations for A and B. For both of them, in B, it asks you what that equivalence point volume is. And then use your data, note the end point volume for each titration, which is given to you in the data, and then calculate the titration error as I defined it previously. So on this page, we're going to calculate that titration error for both of them. Okay. Then using your titration curve and the graphical method, determine the Kb of ammonia. So you only want to determine the Kb for the second set of data. And again, it's going to be the pH that's at the half titration volume. So that half titration volume right there. And then what's the pH at that point? The pH is then the pKb. Okay, so that's how you're going to do that. And of course, you need to indicate on the graph exactly what you did. So that's your summary. That's everything for the summary. Please understand that I do not expect that you're going to do this perfectly. I know that it's not necessarily going to look perfect, but I do expect you to have made an honest effort in attempting to do this. Okay. If you have any questions or comments about how do I do this, what do I need to do, and that is okay. Just let me know. so that we can talk about how we do this method, okay? So that's your lab summary. As far as, let me get out of the lab summary. Post-lab. So in your post-lab, it says if your titration curve data is unavailable, how could you calculate the expected volume of titrant required to complete the neutralization reaction? So if you didn't have a titration curve, how would you do that? Give it a thought. There have been some calculations that we've been doing that you should be able to use to do that. Okay? So give me an explanation of one way that you might be able to do it based on what you've done in the past. Doesn't matter what you say, as long as what you say makes sense. I have no specific answer that I'm looking for there. If a strong base is titrated against a weak acid, will the expected pH at the equivalence point be acidic, basic, or neutral? And we talked about this when we talked about the salts, remember? And we actually talked about this when we talked about the titrated weak acids with strong bases. We had those titration curves, and there were a bunch of them on there, and it said something about where we would expect those equivalence points to be. You need to talk about that. And if you want to talk about a generic weak acid, use HF. Talk about HF and what it would do. And the explanation that they're looking for is within the context of HF, that F minus, what effect does that have on the beaker that you're looking at? Okay. Now, if we talk about the dissociation reaction for HA, a weak acid, it's a generic weak acid. So it has an H, that's a proton that we can donate, so it's an acid. This A is just an anion. Doesn't matter what it is. Could be chlorine, bromine, iodine. Who cares? It's something negative. That's all we care about. You want to show the dissociation reaction. So what happens when HA goes into solution? Then you want to write an equilibrium expression for that. Okay. And then if the pH of a 0.0455 molar solution of HA at 25 degrees is 4.32, determine the KB or Ka for HA. Well, okay, fine. So let's talk about that for a second. I have HA, right? And I know it's going to dissociate, and I'm going to get some stuff, one of which is the H+. I feel comfortable putting that there. This is my R, this is my I, this is my C, this is my E. My initial concentration of the HA is given as 0.0455. And I know that I start with both my products being 0. And I know I subtract one of those, and I add one of those, and I add one of those. Then my equilibrium, 0.0455 minus x, except we ignore the x, and that's an x, and that's an x. And then I have a K value. And I'm just going to put this as the two products, and then the reactant. We plug all of those numbers in to calculate our K. Okay. So one of those values is given to you, and it says that the pH of that solution is 4.32, and that's related to one of those X values. So I know that the H+ concentration is equal to 10 to the negative pH. So you should be able to figure out what the H+ concentration is, and therefore what the concentration of the anion is. And then if we needed to actually calculate the value for the HA at equilibrium, we would subtract that X, whatever that value is, from 0.0455. Okay? So that's what we would be doing there. And that would give me a numerical value for Ka, which I would then report. Okay? And that's what you're looking to do. Now, if HA is titrated with a weak base that has a Kb of 2.6 times 10 to the minus 6, would the pH indicate an acidic, basic, or neutral solution at the equivalence point? So now you're going to have a Ka for the acid that you're talking about, and a Kb for this weak base. When we talked in the lecture, one of the slides, sorry, I gotta move this thing. Come on, move. Okay, fine. One of the slides that we talked about has this table. Here it is. And it says calculate cation from weak base, anion from weak acid. And it says that if Kb is greater than Ka, it's less than 7. So you need to do a comparison here to see whether it's going to be above 7, below 7, or 7. Okay, that's what you need to do. That's what they're asking you, right? So if it's below 7, it's acidic. If it's above 7, it's basic. If it's 7, it's neutral. So that's what they're asking you to do there, is compare Ka and Kb to determine if equivalence point at 7, above 7, or below 7. Okay. If 25 mils of HA is titrated with a 0.0600 molar KOH, what volume would you expect to be required to reach the equivalence point? This is a stoichiometry calculation, and it's very similar to some of the things that we did in this lecture. I'm going to ask you to do that calculation on your own. I will tell you that you need to find the so you will need to use the concentration of HA from C. Okay, so your concentration is given C. The volume is given here, and then you have a molarity for the KOH given here. So you should be able to use the molarity and the volume for the HA to figure out the number of moles of HA. Once you know the number of moles of HA, you should be able to determine what the reaction between KOH and HA looks like. So HA plus KOH should give you some products, one of which is H2O, because that always happens when we do a neutralization. And the other thing is whatever's left over, which would then be that Ka. Okay? So that's the salt that we make as well. So based on the stoichiometry of that, you should be able to tell me what the molarity of the KOH is based on the information that you've been given. Okay, so calculate the number of moles of HA. And then use the volume, KOH, and the stoichiometry of HA to KOH, and that should give you the number of moles of KOH and the volume, which gives you a molarity. Okay, so that's the expectation there. And that's it. All right. So these things are all repetitive of work that we've done in the past. Okay. So hopefully you're comfortable or getting comfortable with doing these things. Remember that you need to find what the H plus concentration is here, and that you can do from the information you've been given. So I don't anticipate a huge number of problems, but I know what I'm doing. So it's hard for me to say. Like I said, your data for this lab comes from these pieces of paper. Okay, so it's not from what you do in the simulation in ALEKS. That simulation has been given to you so you can see what it would have been like to do this experiment in the laboratory. And that's it. That's all it's for. It's just informative. So you get some points for doing it, but it's really just informative for you. Okay, well, that should be everything. So if you have any questions, comments, problems, anything like that, please let me know. We'll be more than happy to help. But I am done recording this, and I think that's going to be it for today, but I don't know. So I will get some more recordings done for you shortly, and we should be well on our way to being where we need to be. Okay? Let me know if you need anything.